Alright, let's talk about exponential functions. So we're talking about functions of the form a raised to the x. A is just some constant. Alright, so maybe we're talking about something like y equals 3 to the x. So the a value has to be greater than 0, and it cannot equal 1. If it were equal to 1, the whole function would just become 1, right? Because 1 raised to anything is 1. So we're looking at an example of what we call exponential growth. You can see how it's growing exponentially, so very quickly. Okay, an exponential function will always pass through the point 0, 1. Right? If you put 0 in for x, you'll always get 1 out for y, since a power of 0 is always going to give us 1. Recall that we're going to have a horizontal asymptote here at y equals 0. That function, that part of the curve, will get very close to it, but it'll never dip into negative territory, and also never equal 0. If you were to think about something like y equals 3 to the negative 10, all right, remember this is really 1 over 3 to the positive 10. So you're getting closer and closer to 0, but you're never going to hit it, and you're certainly never going to go into negative territory. So your domain is all reals, your range is all y values greater than 0, but not including 0. Okay, so that's exponential growth. Alright, and so now let's talk about exponential decay. That's where we have a raised to the negative x. Now our domain and range are going to remain the same. Okay, here it is exponentially decaying, or it's going down very, very quickly, and then it starts to level off. Notice how it still goes through the point 0, 1. And if we compare this a to the negative x to the a to the positive x up above, we're really just looking at f of negative x. So in other words, we're just negating the x value on the inside here. So notice how that is really just a to the x reflected over the y-axis. Okay, so if we were to compare these two graphs, they're the same graph, but one is just reflected over the y-axis to get the other. Okay. Alright, so let's now look at a special number which we call e. So e is a very popular irrational number. It's very similar to pi, okay, but e is approximately 2.718, and very often we will see problems that deal with the function e to the x. It's another exponential equation. Okay, it is going to pass through the point 0, 1. Alright, so this is probably the most popular exponential equation, especially in this course. Alright, IB loves e to the x, so be familiar with it. Alright, e is not a letter or a variable, it's a number. Okay, so know what its function looks like. Okay, it typically shows up as the base in an exponential function. Okay, I suppose we can also look at e to the negative x. Okay, if we compare this to e to the x, well, we know what e to the x looks like. E to the negative x, well, that's a reflection over the y-axis, so it's still going to go through the point 0, 1. All right, but that would now turn into an exponential decay graph. Okay, so again, it is really what you see up above, but it is dealing with negating the x value. Recall that f of negative x means that you have a reflection over the y-axis. Okay, the little r is our symbol for reflection. Alright, so what we're looking to do now is we are going to be starting with this given function 2 to the x. Okay, so we have an exponential function here, and we have some transformations going on. Alright, we'll look at these one at a time, and we're just simply looking to describe what's happening. So in our first case here, we are starting with 2 to the x, and then we're adding 1. Okay, so we're adding 1 to our f of x graph. Okay, so it's really the same as writing this as f of x plus 1, right? Because f of x is 2 to the x. Okay, well, recall from earlier we said that when we add 1 to a function like that, we are going to shift up 1 unit. So we say we have a vertical shift up 1. Okay? Okay, suppose we have this new function which we're calling h of x, and you see 2 raised to the x plus 1. So this time the plus 1 is part of the power. So this is really the same as doing f of x plus 1, right? We drop that x plus 1 into this function here where we see an x, and it became 2 to the x plus 1. So this time it is not going to be a vertical shift. Instead, we're going to have a horizontal shift, and since we have a plus 1 on the inside, recall we would be shifting to the left 1. So we'd have a horizontal shift left 1. Okay, so now we have a new function which we're calling q of x, and this time it's defined as negative 2 to the x. Well, notice that is the negation of our original function f of x, right? And when we negate a function, recall we said this is a reflection over the x-axis. Okay, so we'll just jot that down, either using the shorthand notation or we write it out in words. Okay, and our last one here, suppose we have r of x, and this is equal to 2 raised to the 4x. So notice we had 2 to the x, now it's become 2 to the 4x. So that means we put a 4x into the function. So we have f of 4x. Okay. So in this situation, we have something going on to the x value. All right, so that is a horizontal either stretch or shrink. Now, since it's a number greater than 1, we said this is going to be a horizontal shrink, and the scale factor, SF for scale factor, this is equal to 1 over 4, so the reciprocal of that 4. Okay, so we would see this compress horizontally, right? It would shrink horizontally, and it would shrink by a factor of 1/4.